Hello there, welcome back. This is Santosh again, your host for the day. I think we are quick enough to be back. So we have Dr. Anandan out here, who's going to be addressing potential and use of AI to solve social challenges at scale. Amazing. Welcome, Dr. Anandan.
Yeah.
And then, and then we have Mr. Aditya, who's going to be associated along with Dr. Anandan in this particular keynote talk, or the talk as well. Over to you, Dr. Anandan.
Okay. Thank you, Santosh, and thank you for the organizers for inviting us and giving us this opportunity. So I'm, as he introduces, I'm the CEO of Vadvani Institute for Artificial Intelligence. So let me quickly explain. So we are an independent, not-for-profit. We've been around for a couple of years with the exclusive and sole purpose of developing AI-based innovations and solutions for the wide variety of social sector problems. I mean, naturally, if you look at social sector, we are talking about probably in India itself about 700 to 800 million people, and worldwide probably close to 3 billion people, whose lives today are not much affected by the type of AI that you and I use. I mean, they're not doing ride share, they're not doing much of e-commerce and those kind of things, and eventually self-driving cars will also be meaningless. However, their lives are actually more likely to be served by what AI is capable. I mean, basic things like basic livelihood, which is agriculture usually, basic level of healthcare, which is saving maternal lives and children's lives, infectious diseases, and a wide variety of other things. A basic education, not the high school, college education, even more fundamental than that. Basic level of infrastructure, city management, and things of that sort. And not last but not least, being able to get credit and being able to get loans in the right way and things of that sort. So all of these, in fact, are one of the reasons that they are not very successful is a lack of significant human expertise and human capacity. As I'll explain in some of the stories that we are going to tell, you'll find in each case that it's lack of experts like doctors, medical professionals, agriculture experts that actually limits the capability of poor people to survive. And in fact, AI might turn out to be a very good benefit there in terms of augmenting whatever human systems are there with the ability to do rational reasoning and such. So when we think about AI, we don't think about the AI technology alone, because AI technology alone in itself is not going to do anything unless it's couched in a product. Actually, I heard Sailesh Kumar speak a little bit before me, and this idea of product oriented use case driven thinking is quite fundamental to any practical use of AI, and social sector is no different. Also, again, in the social sector, similar to the commercial sector, but perhaps even more so, a product alone does not constitute a solution. We may have a significant human service component, deployment component, backend service, and such. Unless you are able to provide that along with the product, it's not going to be sufficient. Especially because we are dealing with systems and situations where the technology skills and technical skills may not be adequately there. And of course, all of this will only scale if they are part of some kind of a system. So take healthcare, for example. If you actually have a solution that might work in a small community or a village or a city, that's actually not enough when it comes to a country scale problems. So you need to have national or at least regional level systems that can leverage the solutions that you produce. So when we think about AI and how to choose the problem and what to do, in our work we've always been starting with these 7 questions. First, we ask, is this problem a big problem? Of course, we don't know ourselves how to answer that question, but we work with a lot of partners in the social sector, government organizations, agencies, international organizations that are conveners of social sector organizations. And when we talk to them, we understand the importance of a certain problem and whether we should look for a way to solve it. And of course, solve problem may be great, but not all problems can be solved by AI. So we are hopefully capable of assessing whether AI can help. But even if AI was there, sometimes the real problem may not actually be in what the AI can do. It may be simply distribution of medicine or vaccine or something, in which case it's not necessarily an AI solution, more boots on the ground. So if that's really the critical problem, then you shouldn't be trying to solve another problem, which is an AI problem, which may not make a lot of difference. Not that you can't solve it, but it may not make a lot of difference. But then even if you do all of that, there's going to be a lot of confusion about the solution and its use and its potential for interfering with the stakeholders' current workflow and so on. So you have to get into a conversation with the stakeholders, who may be anyone from public health officials, agriculture secretaries, ground level staff that have to use it, and make sure that they will accept the solution. with all of this, let's say we are ready to launch, but data is always a problem. More so than commercial sector. In social sector, there are no natural incentives for people to give data. When you and I use social media, or when we use commerce, the system is already collecting data about your behavior that it is using to learn. In social sector, there is no such self-starting method. So you have to actually instrument data collection methods. You have to make sure that the data can be acquired through various means in a safe way, and that it has to be cleaned up. It's actually a fairly significant challenge, but one, as you can see, you can actually meet. Then, of course, you do all of this, but you as an innovator on AI organization, you are not really equipped to pilot and do things up to scale, because you don't have the experience of working on the ground, nor do you have the credibility with the respective responsible agencies. So you need to have a partner to co-create, or partners to co-create and pilot and take it to scale. And last but not least, the pathways to scale will really depend on what I said originally, which is the systems level approaches. So bear this in mind as we talk about some of the work that we are doing. Fortunately, although these questions seem almost difficult to answer all in positive, we are able to find examples of doing that. Now, one of the key things we realized when we started doing this work, there is this circle that's typical of any kind of product development. You choose an area, identify a use case, and start working on it. Collect some data, produce some technology, a proof of concept, and do some solution development, pilot it, and of course you will iterate many times on this until you say, okay, it's ready to be given away to scale. Now, the unique thing about a social sector problem is the skills that are needed for the stuff below, which is field work, data collection, and implementation, lie with one set of organizations, which are typically governments, NGOs, and domain experts, whereas the technology skills lie with a different set of organizations. So what we found ourselves and are finding ourselves is that you really have to be right in the middle. You need to know how to talk the talk of social sector organizations, and how to work with the tech companies to build collaborations. So you have to have tech capability yourself, which is kind of what we are doing. Now, let me begin with an example. This is related to maternal and child health. What you're looking at here, as you'll see in a minute, is a newborn which is going to be weighed using a spring balance. And the woman that's holding the spring balance is a frontline health worker. And one of the ladies, I think the one in green in the back, blue-green, she is the mother. And the other one is some neighbor, whatever. But it takes about 3 people to do this process. And the spring balances need to be noticed accurately and things like that. This process is quite cumbersome. And moreover, I think in many cases, people don't like external people coming and touching their babies, newborn babies. There are lots of taboos about it. And as a result, it's not always very well done. Even though the system has been in place for more than 25 years, for a variety of reasons, the results are not working out. In fact, what we find is that if you look at an ASHA workers chart, this is one particular example where you see over a period of 7 or 8 months in 2019, every baby that the ASHA worker saw was 2.5 kilograms. And that doesn't sound possible, and it's certainly not true. And the reason for that problem is that basically, the 2.5 kilograms is a threshold for when baby is considered a low birth weight, after which you have to do some critical care. And if the baby is below 1.8 kilograms, it's actually, in an ICU situation, neonatal ICU situations. So people tend to, guess 2.5 because the baby looks okay and so on, rather than actually doing the measurement. And this is not an uncommon example. We understand, talking to authorities, that over 30% of underweight babies are not actually properly reported, for example, in different parts of India. And so when we look at how to solve it, we look at it and say, this is a problem which we think computer vision can solve. If, for example, a frontline health worker can take a short video or some photographs using a cell phone, we can use state-of-the-art vision techniques to create a 3D, shape model of the baby, and that model can then be used to compute the volume of the baby. As it happens, newborn babies are almost of constant density, about 1.03. They are mostly water. And now we can use that fact in order to convert the volume to weight. And moreover, in addition to actually gathering weight, if we have a 3D model, we can actually start measuring other important things like head circumference, head to torso length, which are actually quite critical parameters, which are not easy to do for the newborn, as you can imagine, especially in a frontline situation. And so as a result, we are looking at this computer vision techniques, and I'm happy to report that this has made a significant progress, where what we have done so far is in hospital-based settings, we are able to get very high degree of precision and recall. This was actually a few months ago, so I think the technology has improved and the numbers are probably better. But generally, what we are really trying to optimize is not to miss any low birth weight baby. So we try to optimize the algorithm little towards making errors in the case of higher birth weight baby may be classified by lower birth weight, but not the other way about. What you're seeing in the video is a superimposition of the 3D model on top of the video, so you can kind of see it looks fairly well aligned. One of the reasons we are able to do that, even though baby models may be complex, is because baby shapes are a particular subset of classes of shapes. Babies don't look like chairs or computers, so we have a parameterized model of baby that's internationally well known and used, and we have derived from it and are able to create this model. At the moment, where we are is actually saying that can we take this work to home settings? Clinical settings is one thing, and as you can see, though, in home settings, the background may be much more colorful, may not be able to, lighting conditions may not be very good. But however, we find that the technology is doing quite well. On the right-hand side, you see an example of an image where it's pretty dark, but the 3D model looks fairly good in terms of how it's superimposed on the baby. So overall, our goal is now we are at a point where we are entering field trials. In fact, if the COVID-19 crisis had not taken place right now, where we would have been done a significant amount of scaled field trials in places like Rajasthan, Gujarat, and UP and other places. We have a bunch of partners that we are working with. Our hope is to get into a full pilot mode by the end of the year, but now things may get a little bit delayed, but the problem remains and the challenge remains. So as soon as we are able to get up and running, we will. We are also making improvements to the algorithm, so our accuracy numbers will be better. We've done a bunch of user studies on the usability of the technology by frontline health workers, and so far we've found that they're very positive reaction. The idea is, of course, the frontline health workers doesn't have to do anything. Just take the video, the numbers will be calculated and directly reported to the system with respect to the baby's measurements and so on. Now, switching gears a little bit, newborn babies and maternal care and child care is one thing, but one of the big challenges in India are actually infectious diseases. You all know, of course, about the COVID-19 crisis, but there is actually a bigger one that's been with us for a long time. As it says in worldwide, in 2018, about 10 million new TB cases were found, and about 1.5 million deaths happened. In fact, TB is the biggest killer in the world. It kills more people than malaria and HIV combined on an annual basis. About 3 million TB cases go unreported. The remarkable thing is that TB is curable. There are many drugs for taking care of TB, but unfortunately, the system doesn't find enough cases. And in many cases, when people are treated with TB drugs and so on, that they don't take drugs. Why? Because often the drugs have a lot of side effects and they don't make you feel good. So you're supposed to take a drug for, let's say, for 6 months or a year. People start feeling better after about 6 weeks, and then they stop taking it, which results in the bacteria developing resistance to the drugs. So as a result, we have drug resistance TB, multi-drug resistance TB, and what's called extremely drug-resistant TB. And one of the ways in which the system addresses it is to have what are called TB health visitor, TBHVs, actually personally going to people who have TB and watching them take drugs. This is not a scalable solution. So what now we have done in the country is to use a few technology-based solutions. One called 99 Dots, which came out of Microsoft Research India, and there are other solutions came out of other places that are somewhat technology-based. But those solutions also still require a certain amount of cooperation by the user, or technologically they might be cumbersome. So it's not always easy to catch everybody. So what we are looking at is, instead of waiting and reacting to people not taking drugs, can we actually proactively guess who might not be taking drugs? And this is something that's done in other domains, right? In a lot of domains, you find that people's behavior can be predicted not only by actual sort of behavioral data related to that particular situation, but a lot of contextual data about how they behave in other conditions or their background and things like that. So we are looking at AI and machine learning models that can learn from known cases of TB adherence and non-adherence in order to bring in a variety of contextual factors and start predicting certain patient might be more risky, and then address the TB health visitors' attention towards them. So when we know that someone is risky, we can focus more on them. It's basically trying to increase the capacity and reach of a small number of TB health visitors to handle these situations. Now, I'm happy to say that we are working with the Central TB Division in India, which has got the largest purview of TB. It's actually a nationally organized system. Even though we are not able to find all the cases, TB care is actually quite well centralized in India, and we are working with that division to help them with AI-based solutions. Let me move on to a different domain, which is agriculture. And we know that in India, there are about 100 million families. About 60% of Indian population or more are still agriculture driven, and about 60 or 75% of those are actually smallhold farmers, 1 acre or less. And they certainly don't have the capacity to invest in technology, and they are very much about hand-to-mouth existence. Weather patterns and other things can actually significantly affect their ability to produce and survive. There are many problems that farmers face. One of the big important crops in India is cotton, because it's the first aspirational cash crop, and India is one of the biggest cotton producing countries in the world. However, cotton is subject to a lot of pest infestation. There are about 50 type of pests that infect cotton. However, there are only 8 that are significantly dangerous. And large percentage of pesticide, like 55% or plus, is actually used in cotton, and they're not always used well. The problem here is that you have to balance between overuse of pesticides and not using it enough, and using it in a timely fashion as well. So how does one do that? In fact, cotton failures, I'm sure you all know, has been repeatedly the case of cause for a lot of farmer suicides in Maharashtra, which is our home state, and other places. So there is an approach right now where frontline agriculture worker called agriculture extension worker visits the village once or twice a week, and he works with a few farmers, one group of farmers called the lead farmers, and tries to give them a lot of advice. And one of the things that they have been trying to do is to actually set up these insect traps. There are 2 kinds of insects, those that are called sucking pests. Those are the small ones that you can catch using this yellow sticky trap that you see in the center of this figure. It's just a yellow sticky paper. The bugs just latch onto it. There is also a different kind of trap that's something called bollworms, which are bigger in size, and they are trapped using a funnel-like thing called a pheromone trap, and then they empty it out. Now, one thing that they are supposed to do is to count the number of pests on a daily basis or a weekly basis and report that to the authorities. However, this counting is not very easy, and counting is inaccurate, and partly because it's not easy to tell a pest from something else. So often what happens is the counting is poor in individual forms. So the system tend to aggregate the counts over a block of villages, like 100 villages, and take an action. But the whole process takes a couple of weeks. By the time the decision, to apply pesticide is decided, it might be too late. And you have to be careful, because you have to have a threshold of infestation, which is called an economic threshold limit, before you apply pesticide. And that's a process that is scientifically determined, but you need the good data for that. So what we have done is to actually develop a simple solution where you take a picture of either of the sticky trap or this paper on which these other bollworms have been spread, and we count. And the counting accuracy has now been greater than 99%, and we find that this can actually be used. And right now we are in the process of introducing them into various system levels of care. So we actually got an app that's part of another system. Again, we don't want to do standalone apps, because that becomes a burden on the user, but it's a part of already existing agriculture extension system, and this number will go there, and they can start using it right away rather than waiting for 2 weeks, and also get more accurate numbers. So very quickly, that's the kind of stuff that we have been doing in farming, but really that's a starting point. Our goal is really looking at the end-to-end aspect of farmers' life, from increasing the yield to managing the crop, to reduce the costs, and also bring farmers up to speed on other modern techniques and as such. So let me back out. There is one new problem that we have gotten into, and that is all of these examples. What we find is that there is a certain measurement that you can make. Some of it is subjective, meaning as what people look like in the case of diseases, and what visual appearances are, and so forth. Some of it is objectives. You can do some biochemical tests and such. But in many cases, the caregiver, let's say health, for example, right? A good doctor doesn't simply depend on these subjective and objective measurements. They use a lot of contextual knowledge, which is about the person, about the community, about disease prevalence, and all those kind of things to make a recommendation. Now, can we compile such a knowledge in the form of an AI that can help a frontline health worker do a better triaging, so that by the time people go to doctors, they have a better reason to go, and it's clear who should go and who should not go. I'll give you one example. Risk of maternal life during pregnancy. It's a significant problem, but by most objective measures, more than 60-75% of Indian women are considered high-risk pregnancy, which is not true. However, doctors know when to differentiate it. In fact, what happens often now in poor communities is important critical maternally risk pregnancies go to lower level clinics, and the less important ones tend to go to the higher level clinics, which completely clogs the system. So can we better triage and send the right people to the right places? That's a contextual AI problem we are currently working on. This is funded by Gates Foundation. We look at it as a significant foundational effort for the long term. Now, let me switch gears a little bit. You might wonder, I'm saying all this. We are now presently facing a big infectious disease challenge. What are we doing about it? One thing we realized is very early on, this is an area which may not be fully AI or data science, because a lot of the modeling is epidemiological modeling. However, we are scientists, and we are computational scientists. So we decided actually to start addressing ourselves to this. And at the moment, most of our team is working on COVID-19 related problems, but we are primarily looking at how to use data science to help authorities understand how the disease is spreading at a local level. We're not interested as much of national level prediction as much as wards and districts and cities, so that the city authorities can kind of handle it and take control measures. We were able to convene a consortium, not only as Indian Institute of Science, a number of other companies, as well as about 50 volunteer data scientists from Bangalore who have come to work with us, very actively working on at the moment. And these are some of our partners. You can just see quickly the names. We are also supported by international agencies and technology partners who are good at epidemiological modeling, like the Institute for Disease Modeling, who are working with us. We are working closely with the Bangalore City War Room to help them. And we are at the moment fielding a service online, cloud-based service that cities can log into and put the data for their city and try to model and find out. We've just done a beta release. Hopefully more will be coming in the next week and so forth. In addition, we also realized that perhaps cough could be a potential way of detecting and pre-screening TB. So we are starting to investigate it. Right at the moment, where we are is in the data collection. We just launched a huge cloud source data collection effort. Let me see if I can go to that. So you can see some of these links, and you can go check it out. And we've been getting data from various people. We are also looking at other facility-based data collection as well. Just to back up, see, our mission when we started 2 years ago, there were about 4 or 5 of us, and now we're about 50 people, consisting of researchers, engineers, product managers, and people who can go work into the field and program people. We are growing fast. We have every intention of more than doubling our size in the next couple of years. We've been very blessed with very good funding and very good relationship with the government and other organizations, both in India and abroad. Our charter is not limited to India. One reason to start in India is the digital pipelines that are needed for a lot of these things have been well laid in India. But our target will be to address the problems in not only in India, but also other countries. And we collaborate with local and international institutes and universities in doing our work. Everything we do is done in the open source. It's not for profit. So it's given away for public good for free. And we are hiring, and any of you who are listening to this, please do reach out to us and so on. That's the end of my talk. So I'll leave it at this.
Sure. Thank you so much.
Yeah, stop sharing the screen or whatever.
Yes, you can do that.
Tell me how to do that. That's the problem.
Okay, you just have to go to AirMeet browser, web browser.
This one.
And then you click on the bottom. Yes, perfect.
Good.
Thank you so much. Thank you so much. So I would actually request, maybe there's one question, Aditya, if you can just read out. I know you already answered that to Sonia, but if you can read out and Mr. Ananda can actually address it.
Sure. I'm not sure, it was not entirely clear the question, but I'll read it out. So the question is from Sonia Kirpalani. The question is, we are working on a platform which stimulates discovery, customer acquisition, and engagement for tier 1, 2, 3 SMEs and barefoot entrepreneurs. removing the middlemen, giving last mile assistive technology, payment gateways powering e-commerce. How do we deploy AI insights which powers competitiveness in a cost-effective yet efficient manner at scale? So I think that last part of the question is how do we deploy AI at the which is cost-effective and efficient manner at scale? It's probably.
Yeah, so I mean, I think this question of obviously not specific to social sector, but generally, I think I would take it at a broader level and answer it. So I mean, this is like any other application of any new technology. The more you understand what the workflow is, that's what I call the systems approach or the solution. The better you will be placed in order to understand where AI can work. So if you go back to my different circles, AI, product, solution, and systems, you kind of need to work initially at the solution and products level and have the systems back in mind. And when I say solution is that, let's say, whatever company that's coming to you, you kind of need to understand what are the services they provide, who's using it, where they are using it, and which part of it is where something like AI can actually make a difference, right? Because AI is abstractly, it's learning from data and is able to make some decisions, help people make some decisions. But where does that decision need to be made is something you need to understand by looking at the workflow, and then you can customize it.
Sure. I think there's some more clarity out there, Aditya. I think they are asking from, they are a socio collective. So
yeah.
Okay. So there's some more question I think you can pick up.
Yes, there's another question. I'm just going to read these out. Is there a repository of case studies and areas where the Vadhvani AI Foundation is working on?
Not at the moment, no. We are still in the process of collecting that. There are, by the way, other studies which you write to us and we'll send you where other people have been doing this kind of work, collecting use cases. But what we learned is that abstractly sort of talking about use cases is one thing, but the ground reality about where systems are in place and where the solutions can work is the learning that we are bringing. At the moment, we are just learning and collecting our knowledge. And one very good question, we would like to publish it, but probably not immediately. It might take another 6 months or a year before we feel like we have enough of a study done to be able to do that. So we'll definitely do that.
That question was from Upendra. Next question is from Anup. The question is, there are many startups working on similar use cases in agri-tech, for example, and with varying levels of accuracy. Are you extending your technology/platform for the startups also to leverage for their commercial use?
Yes. So at the moment, again, we are just getting in the game, but our intention is to the extent both, as we can create a platform, which is right now we are working in pest management, which is a vertical. But at some point, we would be going horizontal on looking at end-to-end cycle of a particular crop and so on, or pest management for many crops. Whenever we start extending that way, right, we are not planning to do all of that problem ourselves. It will necessarily require creating a platform onto which other people can come and plug and play. One of our visions has always been to create a AI for social good hub and engage other people. And startups are going to be a very important part of that, because we don't believe that ultimately the not-for-profit, non-commercial approach is a fully scalable, but that's a good place to start because it overcomes some immediate challenges with respect to the need for revenue. But our hope is that, we are able to provide a platform for others to come and engage as well.
Another question from Deepak. Are there any initiatives undertaken by Vadhvani AI which help to ensure that public distribution systems are automated to check distribution of food grains to Anganwadis? So any kind of public distribution.
It's a good question. At the moment, we haven't looked at that, but I would say in the context of agriculture, something similar has come up, which is, in many cases, small farmers, have a little bit of grain and they don't have enough to invest in taking it to the market themselves. Can we actually help in some way of being able to create a collaborative approach to doing that? But we haven't at the moment started working on it. But again, it's on the sort of the sales side, the right-hand side of the cycle, if you will. So we will definitely think about it, but in the future.
Sure then. Thank you so much. Is there anyone wants? Okay, there's one more. Okay, great. Okay.
Is there another question?
No, it's Deepak says thank you.
Yeah.
Okay, if you have any questions, you can drop in, or else if not, thank you so much, Dr. Anandan, and thank you, Aditya, as well. I think it was very insightful, and social concern related, I think a thought-provoking presentation as well. I think we have received a lot of thankful replies as well for this one. So thank you so much, Anandam. I think you can see. I mean, we are not having a physical event, but still you can see virtual, claps, coming up at the bottom of the screen.
Thank you.
Thank you so much. So I think happy to have you here, and then so we'll be back in a few minutes. So until then, please hold on. Thank you so much, everyone.